Hello, everybody. How are you doing? I hope you're enjoying QCon. I think QCon's a great conference. I've been here several times. This is, I think, my second time speaking at QCon over the years, but I think it's a great place to meet vendors and meet other people that are looking to solve problems, share ideas. So I think it's a wonderful conference. Obviously, this session here, we're going to talk about this buzzword, agentic AI, and what does that really mean, okay? And so hopefully I'll be able to provide you with some new information that you can take back and mull over and you know, take what's useful and what isn't. So our agenda, my name is Duncan, and I am a senior director at a company called Akka. You may have known us before as Lightbend, and we build pretty large-scale tools and platforms for building distributed systems, right? And so distributed systems we're going to talk about a little bit here in regards to agentic AI, but we're talking a magnitude of hundreds of thousands to millions of transactions per second, and scalability across different regions and different cloud providers and so forth. Our stuff has been downloaded over 1 billion times and powers roughly around 100,000 plus applications around the world. You might have heard of one called Fortnite. But so there's a lot of stuff that we do here. And one of the things that we're going to talk about or primarily focus on today is this idea of agentic AI. What is agentic AI? We recently found out that the term agentic AI in Google search has increased over 1,500% in the last 4 to 5 months. And so it's a very popular term, and it's a very powerful idea, but it also, you know, with great power comes great responsibility, right? Isn't that what we learned in the Spider-Man movie? So there's some things that we got to think about when we're going to start integrating this type of technology into our services. And some of those challenges we're going to address in this speech or in this presentation. And then I'm going to provide for you what we believe is a blueprint on how to solve these problems and some of the key components that are required. And whatever time is left over, we'll have a little bit of Q&A. So what is agentic AI? What does agency mean, right? We can kind of think of it from a human perspective, right? That is the absolute highest level of agency on planet Earth, are humans, okay? But now we have these things like artificial intelligence that are accessible to the general public, and they're pretty cool. They can do some really neat things, these large language models. And we'd like to know how we can integrate some of those large language models and those ideas into our applications. So, but before we get there, let's try to get a definition of what this means. And why not ask ChatGPT, right? It's the super smart AI. Let's see what it says. And it basically identifies 5 important parts about what agentic AI is. And so some of those parts are this idea of goal-oriented reasoning and working autonomously with minimal oversight. I say reasoning with quotes around it because I would argue that there is no LLM in the world today that actually reasons like we do, right? You're using matrix math, you're using analysis prediction, and all these different mathematical constructs to get data or to get results back out. But it kind of mimics the idea of reasoning, you know, proactively acting and reducing the amount of human intervention that's needed. You know, like I mentioned, goal-oriented reasoning, basically being able to plan and execute tasks independently to achieve a desired outcome. And there's a lot in that sentence I just said there, right? Even for a human, if I'm going to execute desired tasks for the desired outcome, there's all kinds of stuff that I got to know about context, if you will, context data in order to achieve the desired outcome. And we'll see some analogies to that. Autonomous adaptability. One of the things that you're going to need in these types of applications are self-healing, things like auto-scaling, and not only up, but also out. And ultimately, that leads to multi-region, multi-cloud type things. And the core capabilities of these types of systems are going to be independent decision-making, problem-solving, self-optimization, all the things that we would do as a human being. If we're going to train for a marathon, we're going to optimize by running on a daily basis, all these types of things. We're going to want these systems to be able to do that and the efficient handling of complex tasks. So when you look at something like the ChatGPT interface, I had someone came up to me today and they told me that I thought an LLM was a database. It isn't, right? All the magic that ChatGPT and Gemini and these other interfaces provide you is some of the stuff that we're going to be talking about that's built around the LLM to give you those capabilities. So what I like to do is I like to start with the feedback loop because this is going to be very important. We're going to talk about something called the agentic loop. And a feedback loop is this iterative process. And here I use it for booking. So booking to come here to this conference. Booking is always, maybe it's probably me, but booking to me is always a very egregiously painful thing, right? Because, I want to be responsible financially. I'm not going to pay for the most expensive flight. I live in an area where I can't go to my local airport because it's like multiple planes to get somewhere and 3 times the cost. So I have to go to a much larger airport, which is potentially anywhere from 2 to 4 hours from where I live, depending on how I get there. What airline am I going to take? What airlines am I members of so I can get more points? Where am I going to stay? What am I going to do when I get there? There's just so many different data points that I have to deal with, and I have to keep checking and figuring out what works, and then I get information back, and I'm like, no, that's not going to work for me, and so I go through this standard feedback loop. Feedback loops have been around forever. And I check my results, and if my results are okay, then I move on, and eventually I come to my answer that provides my itinerary that I want for my travel arrangements. And when you're using agency and agentic AI, you're going to be doing this exact same thing in a large majority of the scenarios. Another good example would be sculptor, right? I remember, or I'll go to oil painting. I remember I was painting an oil painting and I messed up the hand on the person I was painting. And my dad said, no problem. He just took some oil, or not oil, but alcohol and just, I'm like, oh my gosh. He goes, now redraw it with a pencil and repaint it smaller, right? And so that's a feedback loop, right? I painted, it was wrong. He looked at it. He augmented, right, that conversation with the canvas. And then we went back and we did it again. And this is what you're going to be dealing with in these types of systems. Now, we're all very familiar with these AI assistants, ChatGPT, and the wannabes, Siri and Alexa, right? They'll get there eventually. They're not there now. But they're very powerful. And one of the very important hallmarks of these interfaces is this natural language that we can express ourselves in, right? So we can talk to it like we're talking to another human being. We get a response back. We look at that response. We decide whether it's right or not. And we go through this whole thing. This is why things like prompt engineering are going to become an invaluable skill, understanding how to interact. And what we're seeing now is this evolution migrating from these things of agentic agency, right, or assistance, I'm sorry, when we're moving to agentic AI. And in these AI agents, now they're going to start to do things that are going to be more autonomous, right? So if you think about the feedback loop and you think about the travel booking idea I gave you, if I give additional capabilities to my agent, like access to my bank account, access to my schedule, and what I want to do and where I want to do, it can go ahead and book all this stuff without my intervention, and then it can send me back an itinerary for my approval, and then I can either deny it or accept it, right? And so that's where we're moving to. And so people like Agentforce for Salesforce and Workday and other companies, they're beginning to think about this type of processing of data and managing of data and using these agents, these digital agents, if you wish, to solve problems. So this is kind of like this evolution here, right? On the left-hand side, we have the lowest level of agency. You may be familiar with RPA, robotic process automation. And it's relatively low agency. Well, today it's much more it's a higher agency, but when it started, it was low agency. You needed lots of inference and supervision. And as we move to the right, we begin to see a couple things. First, we go to agents, and then we go to agentic, and obviously the highest level being humans. And you'll see the criteria on the left adapts, right? It becomes adaptive, it's goal-oriented, it's proactive in solving problems, and autonomous. But on the bottom, your economic productivity and your costs begin to increase. Anybody that's built applications using LLMs, you'll realize that they can become very expensive very quickly if you're not careful, and that's why agentic systems are very important to help solve those challenges. We believe that this agentic AI is going to be the fifth wave of compute. This is going to be something that you can't ignore, okay? Your first wave was mainframe. When I started programming a long time ago, I used punch cards to program in Fortran, right? And then I moved to COBOL, DB, and JCL, job control language. And then we moved into minis, and then, computer networks. And eventually we got to the web. And I don't know if you'll remember this or not. I could be dating myself, but Microsoft, when the web first came out, they're like, whatever, this is just a fling. And then 6 months later, they completely changed the direction of their company. That's significant, especially for a company the size of Microsoft, right? And so you can see users here, as these waves have hit us, the cloud, we went from thousands to millions to tens of millions to billions, where we are right now with mobile. And based off the stuff that we've researched, we're looking at potentially trillions of users. Now that's staggering, right? If you just think about your applications you design, your TPS, your RTO, your RPO, recovery time objective, recovery point objective, all these important business concepts that have to be part of your application, security, compliance, it's just endless. And when you're talking about trillions of users and potentially millions of transactions per second, what, you going to write that in Python talking to MySQL? So I'm not putting down those technologies. I think they're incredible, but MySQL is a perfect example, right? When the web came out, everything was good, and all of a sudden, everything wasn't good. So we basically threw all relational theory away, flattened our tables out into these huge columnar tables, and so when we executed a query, it was one query. It wasn't no joins, no inners, no outers, none of that nonsense, and so it was fast. But even that began to become a problem as we closed in on mobile, and the number of users and transactions per second increased. So, and with Agentic, it's going to be absurd. It really is. Because you think for every one thing you're doing, you may have 5, 10, 15 agents. You may spin up sub-agents, right? And you're going to have to manage all of this. And so Gartner calls this a paradigm shift. Right now, roughly 1 to 4% of applications are embracing agentic AI. Gartner says that with these strategic 10s by 2028, 33% of these applications are going to be powered by some form of agentic prowess. So the question you got to ask yourself is, are you going to be in that group, or are you going to be in the other group? And what does it mean if you're in the other group, right? Look at the old Netflix versus Blockbuster competition. Who won there? Blockbuster was $1 billion company, but they rejected the waves that were coming. They no longer exist, and Netflix does. So it's going to be something that we can't ignore, and we're going to end up seeing this symbiotic existence between our SaaS applications and our agentic AI services. So what are the challenges? I've been talking about this, but let's actually dig in and see what some of the challenges are. The first one is this agentic loop, right? When you're talking to an LLM, anybody that's used ChatGPT, you can, especially if you're using like the reasoning model, it might be 5, 10, 15 seconds for it to compose the answer to you. And we're not used to that, right? Imagine if every update or create to your relational database took 5, 10, or 15 seconds. You think you'd stay in business long, right? So these are things that we're going to have to manage. And how are we going to manage those things? And this agentic loop, where we're going back, these feedback loops over and over until we're getting to where we want to be, it's going to be very challenging. If we don't, well, I'll get there in a second. I don't want to explain the solution yet, but you're going to need things like non-blocking concurrent APIs that can handle concurrency. Blocking is going to be an absolute no. Right now we can build what we kind of call distributed applications by building stateless, single-threaded, using Kafka queues and stuff like this, writing to databases, and we can load balance them, right? But you can see what happens in that scenario, right? If one server gets overloaded and it can start a cascading collapse. So we're going to need to think about designing applications differently. Our stateless writing to a queue in a relational database is no longer going to work, right? At least for these large scale type applications. LLMs are non-deterministic, right? I ask you, what's your name? My name is Bob. Oh, okay, cool. What's your name? My name is Harry. Wait a second, I thought you said your name was Bob, right? That's something we're going to have to manage. It happens. Hallucinations, right? With Agentic AI, you can drastically reduce the number of hallucinations that your database or your LLM gives you. Andrew Yang has a great video on this, and he talks about comparing ChatGPT 3.5 wrapped with an agentic system versus ChatGPT 4 without it. And the quality of the response from the agentic wrapped 3.5 is like 30% better. So, these LLMs are sequential. They generate sequentially token by token, and each new token depends upon the previously generated token, right? So this is a very different way of thinking about how to solve these problems when you have these new problems added to your development agenda. Big point, transactional versus conversational. We're used to a lot of transactional, right? We execute A, B, C, D, D fails, we roll everything back, right? This is going to be much more conversational. If you're familiar with actor-based systems, right? And message passing, where they send messages back and forth. And you talk about things like guaranteed message delivery. Do I need guaranteed message delivery, right? So there's things that you're going to need to think about. In the real world, it's very conversational, right? There's no guarantee if I send you a letter through the mail that you're going to respond back to me, right? So now you have to decide things like this. Are these things I have to worry about in this new environment, because the way that I'm going to build these applications are going to need to be different. So in here on the left-hand side, we have the SaaS application, which is basically transactional. In the middle, we have an agentic service, and that is going to be orchestrated, it's going to be stateful, it's going to be able to manage historical context, and most likely it's going to be event source based, having an event store, because you're going to quickly find out using the same pipe for reading and writing is not going to work either. That's going to have to be split because of the volume of data. Like I said, with the mobile era, we kind of were able to fake our way through it. With this era, it's not going to happen. And then the agentic service is going to kind of either be a separate microservice that works with your SaaS services, or you're going to merge the two together and they're going to work in conjunction. These conversations are stateful, right? When you don't really realize that when you're using ChatGPT, but when in reality the LLM does not remember the conversation. There's infrastructure built around that that's able to do that for you, right? Part of it's in the web interface, part of it's in the back end that's talking to the LLM, and et cetera. And so this is something you're now going to have to deal with. And as your conversation gets bigger and bigger, because the LLM doesn't have state and you have to upload the entire context every single time, right? It's kind of like event sourcing. You start to record events, and now you have 10 million events, and every time you want to decide what your current state is, you got to replay all 10 million events. So what's the solution to that problem? Snapshotting, right? You're going to take snapshots of current state along the way, and you're going to probably end up having to do the same thing here with LLMs if you're doing very complex solution problems. And we'll talk about other things like multiple LLMs and small language models and things like that a little bit later. But this conversational history is going to be stateful. And, it may be a conversation that you have over days, right? That can be a lot of data. The other thing is as you begin to add all these new users, these agents to your system, you're going to have some type of orchestration model and patterns to use them. And so in this example, if we go back to my booking example, we have an agent here that's going to book my travel for me. It's actually going to be multiple agents. But some of my flows are going to be sequential. Like, for example, I got to pick a locale and dates. Right? First, I'm going to, I might know the dates before the locale, or I might know the locale before the dates. But generally, I'm going to have to pick those two things and then come up with a travel plan. And that's my context, right? I want to fly. I don't want to take a train. I want to rent a car. I want to stay in at least a 4-star hotel, or whatever the thing may be. Tuesday night, I have some time off, find a play or something for me to do, etc. Then we move to like a parallel step. And it doesn't necessarily always, it's not always in this order, but in this example it is. And in that parallel step, I'm going to do things like check multiple, potential flight searches for, who knows, whatever airline you're using. Simultaneously, I may look for rental cars and hotels. I may I hate it when I travel and I go to an airport that's an hour from my hotel. I want a closer hotel. Right? And so all these decisions, these are part of your context that you're going to end up sharing with the LLM. And we haven't even started talking about augmenting your context yet. We'll get to that in a minute. And so you have these different things, and then you're going to have some event-driven things, right? That's going to be for your context. You're going to have a state machine. You're going to load some of this into memory, because you're not always going to want to pull even from the event store, even though it's fast, right? Your projections are pretty fast. You're going to want to keep some level of context in memory to be able to address these issues quickly, because you're going to end up doing this at real time, and then with things like RAG and CAG, you're going to sideline into your context, and that's going to need to be in real time too. And you're going to be able to make, your agents are going to have to make quick decisions with this new information from the LLM, a new maybe semantic data from a vector database, and all this other stuff. And then you have task chaining, right? Some of your agents, you may break out into sub-agents, and you may apply like a router pattern or a scatter-gather pattern or something like that. And if you're familiar with the distributed computing, you're gonna start to come to this conclusion here is like, wait a second, this sounds a lot like distributed computing problems, right? Because it's the same thing. CAP theorem, your memory model is different in distributed computing than it is in a typical n-tiered application, and so forth. So these are some of the challenges that you're going to run in. And then orchestration is going to provide you with several different types of levels of agency. Some of this agency is going to be surrounded around it's going to be surrounded around this idea of augmenting, right? So LLMs learn, then they have a breaking point. And that cost of learning is incredibly expensive. Some of these LLMs are 100,000 GPUs at $30,000 a GPU, okay? And to train some of these models, we're talking gigawatts of energy, right? The last training of ChatGPT required more energy than the nuclear power plant near where I live produces. It required more energy than the aluminum smelting plant in Dubai, which uses 5 gigawatts, right? So there's a lot of issues here. So if I stop there for a second and say, then why do we want to do this, right? Go back and ask ChatGPT to do some stuff for you, and you'll quickly recognize why you want to do this, because it is incredible. It can do a lot of amazing things. It can help you solve problems a whole lot faster. Look at the new IDEs that are coming out, Windsurf and others, helping you write code, understanding your code base, and so forth. You're going to have environmental controllers that you're going to have to deal with, streaming sensors, right, IoT and edge devices, and self-learning, right, reasoning. And your agents are going to want to be able to do that. They're going to be able to learn the data they get back from the LLM and whatever information they're getting from maybe a vector database or a memory database, and learn and make decisions based on that, and then execute on that. So again, this augmentation cycle. As a human being, if somebody starts talking to me over here, right, I can actually kind of manage both discussions, but I can get overloaded if I'm not careful, right? I might say, hey, hold on a second. I got to manage some back pressure here. Yes, what do you want, right? And so these are things that you're going to need in your toolkits, right? Your toolkits are going to have to be able to do this. And as I had mentioned, this iterative augmentation cycle, this conversation journal is going to get bigger and bigger and bigger and bigger. And imagine if every time we chatted, I said, hey, Bob, how are you doing? You said, hey, Duncan, I'm doing fine. Now I'm going to ask you what time you're going to go to dinner. But I have to say, hey, Bob, how are you doing? Hey, Duncan, how are you doing? Hey, Bob, would you like to go to dinner? You know what I mean? Every time we have a conversation, I have to re-say everything. Think about that a second. So managing that, how are you going to manage that? And these are some of these challenges that we're coming across and dealing with. And so, you know, they're very serious, very difficult challenges to overcome. How do you overcome them? Again, I had talked about this earlier, but streaming, right? Streaming, bimodal, bidirectional, back pressure managed, asynchronous, in parallel, right? It's out of the box, got to have that behavior. If it doesn't, it's not going to work. Like, you may be able to fake it for a little bit, but you're going to have some problems. We did a application for a customer to talk to Gemini, and we pulled down the Gemini adapter, and within like 5 minutes, we knew it wasn't going to work, right? It was blocking, it was asynchronous, and that was never going to work because we had bimodal communication. We needed text, audio, and video. And so we wrote our own. That was bimodal and was asynchronous and, you know, had all these features in it. And then we were able to, you know, roll out this Agentic app. So streaming is going to be the way that you communicate, and you're going to have all these different data points that are coming in: humans, audio, video, sensors, you know, binary data. It could be text data and so forth. And these are all real-world problems that actually have been solved already in the distributed computing world. Some of them have been solved by people writing very custom systems, and they have expert, you know, 10x engineers managing it, and others there's platforms out here that can manage all of this for you. And, but these are the concerns that you're going to need to think about. And then the efficiency of your system, as we talked. You know, typically with SaaS applications, you know, in the mobile wave, we're talking billions of users. It's going to be 20x that, you know, close to potentially trillions of users, right, in the agentic wave. Your transactions per second, you know, going from tens of thousands or even 100,000 to millions. That's a big deal, right? Your latency, because LLMs can be latent, especially as that conversation goes longer. How are you going to manage that? That's not something you have to deal with as much in today's world. And your cost, right? Your token cost of speaking to the LLM. These are all things that we're going to end up having to manage and take care of. Now, the cost of the LLMs have come down as time has progressed, and hopefully they'll continue to come down, and there'll probably be some more efficiencies. But ultimately, I would argue that we're going to want to look at LLMs as more of a black box and build our agentic systems to be able to interface with them and take care of these individual problems that we're going to potentially run into with this type of architecture. Again, Gartner did a test, or not a test, but they did a survey. And in this survey, they found out of all the companies, of over 1,000 companies that were trying to take agentic systems to production, 52% of the efforts failed to make it to production. Now let me ask you a question. Who in here thinks they would last long in their job if 52% of the applications that they rolled out to production failed? Anybody? Yeah, exactly. So, all right, one person, there you go. But it is a challenge, and the ones that made it to production, they were taking 8+ months to get there. That's a pretty long life cycle to develop an application, right, in today's modern world. And so taking a look at that, thinking about that, realizing the impact that that has is significant. And it's something that we, you know, it's kind of like as you're going to go out and you're going to do this exercise, let's count the costs. right? Let's figure out what is going on before I get there. My brother used to say, he has a rule called the 7 Ps, proper prior planning prevents piss poor performance, right? So, kind of thinking through all these challenges. And like I said, prior to this wave, mobile had started to stress us, right? With all the TPS and all these types of things, the number of users. We began to see the cracks in our traditional n-tiered architectures, right? With agentic AI, it's just going to come by and just wipe them out, okay? Because of the volume of data that you're going to end up using and end up processing with, the number of users that you have, and all these type of things. So whatever your business RTO and RPO is, right, that's going to be affected too. You got to think about those types of things. So one of the questions that we have, or that we get asked a lot of times when we're talking about agentic AI apps, and I'll give you an analogy as a second, is are agentic AI apps going to replace SaaS apps, right? Or another way to put it is AI going to replace human developers, right? So I would tell you that the answer to that question is no. They're not, at least in the near term, in the next 5 to 10 years. They're not going to completely replace SaaS apps, right? Because there's a lot of things that SaaS apps do that are required, and so they're going to, in my opinion, they're going to work in conjunction with these agentic type services. So I would tell you that when you're building an agentic service, there's 2 approaches you can use. One, you can build the agentic service. You may not like the term microservice, right? Some people like it, some people hate it. But it's essentially another project, right, that has endpoints in it that can communicate with other services. That's one way. And that's a reasonable way to build it. I think a better way is kind of like the merging of the 2 ideas, right? When you merge your SaaS app and its behavior with your agentic agenda, right, and what you're trying to do in there, you can begin to do things like shared compute, right? You can begin to do things like sharing the same type of cluster management and the same type of Kubernetes infrastructure and all these types of things, as opposed to setting up it as a separate. But really, you need to sit down and think about, for your particular use case, which one of those approaches is going to work best. Sometimes doing it as a separate service is better because you have a group of people that are specialized or whatever, and they can take that service from cradle to grave, right? Other times, your team may be broader, and it might make more sense to have these applications. Now, if you're going to merge them, there's a new problem that comes up. You might have to rewrite your SaaS application, right? Because the technology that you're using in the agentic service is going to be, or should be, some type of toolkit or platform that is implicitly distributed. So what does that mean? It manages things like region replication, active data replication, right? It uses constructs like conflict-free resolution data sets for instant replication across nodes inside a cluster. It's going to be able to self-heal, so it's going to recognize that perhaps a node went down. So the application as a whole is going to say, okay, node A went down, I need to spin node A back up. Well, great, node A is back up, but that still didn't solve my problem. What about all the stuff that was on node A, right? The things that were in memory, that were doing calculations, that were doing things. Your infrastructure is going to be able to recognize, and I'll use it in an actor perspective. Let's say we have a 100-node cluster and a node goes down in some kind of game, right? And all the users that were on that node, right, they're having a temporary glitch. That system needs to be able to spin all those users back up within a very fast amount of time on a new node, right? And then it needs to be able to evaluate or rehydrate all that state that those users are on. And it may even have to then rebalance the cluster. Because when it's spinning up this new node and bringing those other users back up, new users are joining, right? So it's going to have to know how to rebalance, how to self-heal, right? So elastic, being resilient. And we haven't even talked about security, compliance, and all those types of things. So these are ideas that some of it we were able to push out of development and let other people manage orthogonally, but now it's going to be a little bit different, right? And some of that's going to work its way into our applications. So what I would say is that we're going to see this, what I think what we're going to see is this change to, probably 70 to maybe 80% of your application will be agentic over the next, 4 to 8, 5 to 10 years. And it's going to be an iterative process. You may start with something simple like just customer service, right? Here are calls from customers. They're going to come in, and 70% of these customers don't need a human in the loop, right? It's either we're recording something, or if a customer says, hey, you sent me the materials, but 2 pieces were missing, right? The LLM can quickly do a search history on this customer to make sure they're not trying to do fraud on us. And then if it passes that smell test, then it can go to inventory to see if those 2 products are available. It can access the customer's address and all that stuff, and then take that information and create a docket and ship it out, right? With no human in the loop at all. And it can do that a lot faster than the human can do it anyways, if it has the right context and it has access to the right systems to get the data that it needs. And I think that's what we're going to see over the next 5 to 10 years. I don't know that, agency, until we get to whatever that thing was called in Terminator, I can't remember the name of it, but until we get to there, quantum computing and technologies like that may have a big impact on these ideas, but that's still a ways off and so forth. And again, I'll go back to the same thing again. Energy, it's still a problem, right? These clusters are consuming humongous amounts of energy. And how long can we support that, right? As communities, nations, as the planet, and that will change, right? As with everything, it'll slow down and get become more effective and more efficient, but that's going to take some time. So, like I said, an example might be in today's world, you're going to, for booking travel, you might go to Kayak or Travelocity or Expedia, and that's going to help augment your searches and booking stuff a little bit. But in the future, it may be like Star Trek, right, where you just make a phone call, right, or you may, on a website, you just say it audibly. Hey, this is where I'm going. These are my limitations. I'm going to give you access anonymously to my financial data so you know what I can spend or what I can't spend. Right there, huge security flags, right? So how are you going to manage that, right? If you're going to have an agent that's truly going to make your life better, right? If I hire a travel agent to do all this stuff for me, they're going to do a great job. They're going to have all these feedback loops. Hey, Duncan, what's your budget? Oh, okay, my budget is X. All right, great. Right away, that's going to filter my criteria for selecting flights, for selecting hotels, and so forth. And so if you wanted to do everything, you may want a hybrid approach, right? You might say, just give me a list of hotels and a list of flights and all this, and then I'll pick it and send it back to you, and then you book everything for me, right? So it depends. They're going to meet at these different levels. They're going to meet you. You're going to design them to meet you where your customer needs to be met, if you gather what I'm saying there. So another question that we get asked is, what about instead of, one of the ways in theory you could get around these large language model problems is you could use SLMs, small language models that reduce the number of parameters that you're putting in. They have 1-bit LLMs. And there's some legitimacy to this idea. If you take a look at 1-bit LLMs, their error rate is obviously higher than the larger language models. And so it comes down to what is your definition of error? What is your tolerance for error? When I worked at an energy company about 10 years ago, one of the things that we did was we would optimize your energy footprint for your campus. What is a campus? It could be, Oxford, Yale, Harvard, all these buildings. And it sounds, oh, that's a neat idea, but boy, is it complex, right? If you're dealing with a college or a business that's in a city that has high rises, you have solar irradiance, how much glass is in the building, what's the mass of the building, how many people are in the building during that time, what is the temperature or weather, weather data and the geography, and we can't pull it from NOAA for free, right? We have to go to the best weather agencies in the world, which are basically a bunch of physicists that charge $30,000 a locale, and they give you minute-by-minute weather data. And that's how you make real-time decisions to be able to give your customer advice on when to reduce their energy consumption or to increase it. You can save money two ways. You can decrease your energy consumption, so you pay less, or you can increase your energy output and sell that excess back to the grid, right? And then there's certain times during the year when the grid is like, hey guys, it's going to be really hot. We can't have all you people running your air conditioners, so we'll promise you $100,000 yearly savings if you make sure your energy consumption is below this level, right? So if the model or that you're using, be it in our case it was an optimizer, today it might be a small language model or potentially a large language model, and it's going to come back with a series of recommendations based on linear algebra and nonlinear algebra to determine where you should keep that energy usage and what you should do, right? We noticed in building 6, nobody's there after 5, so just shut everything down. That'll save you approximately 3% of your total electric bill across a month or whatever. So, so there is some legitimacy to that, but at the end of the day, they still can't do streaming. They still don't manage context as far as memory is concerned. They still have the same problems that large language models have, right? You're still going to have to manage all that stuff. You're still going to have to be able to manage augmentation, right? Whether you're using 1 or 10 LLMs or a mixture, right? And that's all outside of the LLM. That's all stuff that needs to be managed in this agentic environment. So, finally, the blueprint. What do we say is important? What do we say that needs to be done here? What are the components that we're going to need? And this is where I have the greatest respect for data scientists, right, and data engineers. I think they're incredibly intelligent people. And some of them are excellent software engineers too. But that's really not their job. Their job is to come up with the calculations. Their job is to train the LLM. Their job is to do that kind of stuff. Building software applications, especially at this scale, is the problem of a distributed engineer. So how do we solve problems like that? First thing we do is we take a look at the LLM, we understand all of its inadequacies, and we black box it. Okay? And then we come up with a solution to manage with this high volume of data, which in the end, you're going to see is basically a distributed computing problem. Okay? And we need to industrialize that, enterprise-ify your application. So in this blueprint, we have 5 constructs that are very key to this type of architecture. So the first one is streaming endpoints. We've already talked about that a fair amount, but again, bidirectional, meaning the same stream needs to go back and forth. Bimodal, it needs to be able to take multiple forms of communication. One customer we built, it was taking audio and visual, where we were giving Gemini hand signals and saying, hey, Gemini, what is this? And I don't remember the hand language, so I apologize. And Gemini would come back and say, hey, Duncan, that's a C, right? Hey, Duncan, that's a B. And then we'd swap the context, and then it would say, hey, Bob, that's a C. That's a B, right? And that may sound like something simple, but there's a lot going on there. And they need to manage back pressure. And these capabilities have to be implicit in the streaming architecture. The next thing is going to be these agent connectivity and adapters. You're going to be talking to lots of things, IoT data, sensor data, and so on and so forth. And so they're going to need to be asynchronous, non-blocking, be able to run in parallel, right? All these difficult, and anybody that's done concurrent programming can relate to what I'm talking about. Under the covers, concurrent programming can be very difficult to manage properly. And so do you want to spend your time doing that, running semaphores, locks, and all these different things to make sure your stuff's working properly? Or do you want to use something that does that implicitly, right? So the other thing is this whole agent orchestration, okay? Being able to spin up and manage, or not spin up and manage, but be able to orchestrate your agents in a fashion that you can do a workflow, right? And you can, like I said, scatter gather, router pattern. There's a lot of different types of patterns you can use, but you're going to want some type of toolkit or platform that provides these types of features to you. A memory database to be able to access things like CRTD constructs, and it also has to be durable in case it collapses, that node collapses or whatever, right? And spun back up really quickly. And if you're accessing data on one node and then you go to access it on another node, you want to get the same result, right? So these types of constructs, things that are built for that. And then finally, the management of your agents, the life cycle, spinning them up, spinning them down, maybe creating sub-agents like we saw in that other diagram. What happens if an agent crashes? Do I restart it? And again, if you're familiar with actors, this sounds a lot like actor supervision. But what is my supervision strategy for my agent? If an agent crashes, am I going to restart it? Or am I going to stop it and spin up a new agent and reload the context, right? So these are all the types of things that you're going to need to think about. And we've identified these 5 components as crucial to building industrial scale LLMs. And then also over here, right, secure, observable, and scalable, right, meeting these different things. So depending on the region, as I had mentioned earlier, you may need to apply a filter because you may have GDPR regulation, or you maybe have FedRAMP regulation, and that's going to be different based on your geography. Your architecture should be able to handle that, right, or at least give you the tools to, to configure stuff to do that. And so this is what I think we're going to see, right, this combination of between SaaS applications and agentic applications. And it's going to give us some incredibly powerful things. The personalization for our applications is going to be amazing, right? Because now you're going to have all these other components that are going to be involved in this process and are going to be able to augment it, right? And things like operational efficiency, having these things self-heal, having these things be able to recover from failure. At our company, we have a nomenclature, let it crash, right? Netflix has Chaos Monkey. Just let it run through production and knock stuff over. Boy, that's scary, right? I'm going to set up my production environment and then knock stuff down. Ours is, great, it crashed, no problem. It's going to spin back up on itself. You don't have to do anything, right? It's going to bring that context back. It's going to rehydrate its memory and so forth. And then scalability, being able to scale out and up. All these types of things, agentic services are going to provide these features to you. And then, our company, this is a lot of eye candy, I get it, or eye chart. There's a lot going on here. But these are the features that we feel are extremely important for each one of these. So agentic sessions with infinite context. That's why you're going to need a memory database and snapshotting and event sourcing. You're going to want to split your reads and writes so you're not bottlenecking the same pipe, if you've heard of CQRS. You're going to, context sharding, load balancing, traffic routing, all this stuff. If it was me, I would like to work with a product that provides these solutions for me. And so I can focus on what my real issue is, my business solution that I'm trying to build. And, streaming endpoints, we've talked a lot about, agent lifecycle management, orchestration. These components are foundational to what are going to be the platform for agentic services. And so that brings me to my final slide, or the summary of this all, is one of our AI guys, specialists, kind of coined this term A-tier, moving from N-tier to A-tier architectures. And so you're moving from a transactional way of thinking, perhaps a stateless model, and your store being relational, to a agentic type style architecture that is going to be conversational, right? that is going to use things like vector databases for semantic searches and memory databases for augmentation, and, RAG or CAG, cache augmented generation, right? Memory database in memory. So your agent, if it's a durable agent, right, it's going to be in memory. It's going to have potentially some type of finite state machine in it that's managing the current process that it's working on, and so forth. And I think this is where the future is going, and this is going to require us to think differently. And so that's my presentation. Just wanted to mention quickly, this is something that we've been working on for quite some time because we've been in the distributed computing space, and when we realized what adding agents to our infrastructure was going to do, we're like, oh my God, this is a distributed computing problem, right? Because everything's getting bigger and faster, and there's more stuff that we have to do, and we've already solved this problem. So now what we need to do is we need to kind of layer a DSL over top, and we need to abstract out the actual operations of this, right? And so I'll leave it there. We are booth 9. I really encourage you to come down and talk to us. We have a couple demos running this, and my coworker Alan tomorrow is going to basically talk about what I talked about, but he's going to take it to code. And he's going to show you some examples and some code and how you achieve these goals. So I think we're almost out of time, or very close to it. So I apologize, we really didn't get to any Q&A, but please come down and visit us, and we'll be more than happy to help you out. And this 48 hours, come down to the booth and I'll explain it. It's pretty hard to believe, but it's real. So I appreciate your time, everybody, and I wish you'd have a great time here at QCon, and look forward to talking to you. Thank you.